So we are going to talk about inertia here, and we are going to use that idea to help explain what happened to Beaker in the video that you just watched. So to remind you, this is a screenshot of Beaker who was sitting on a stack of books on a rolly chair, and the rolly chair was pushed across the room where it ran into another chair, and Beaker and the books went flying into the sink. So the chair stopped, but Beaker did not. So we're going to start right off here just by getting down a basic definition of inertia. So the definition we're going to use is that inertia is an object's resistance to change in motion. So if you need to pause for a second here, do that so that you can get this definition into your notes packet. So now that we have this definition, let's look back at the screenshot again. And so if inertia is an object's resistance to change in motion, that helps us with Beaker because Beaker started in motion and remained in motion, right? He flew forward even though the chair stopped. So the problem is that this resistance to change in motion, that's not what happened to the chair, right? Because the chair did stop. So we're not there yet. We need some more detail. So we understand that somehow Beaker does have inertia because he kept moving, but something happened with the chair. Why did the chair stop? So to do that, we actually need to get a little bit more specific and talk about Newton's first law of motion, which is often referred to as the law of inertia because it's very intertwined, but there's a little bit more nuance here. So reading through what this says here, an object at rest will remain at rest unless acted on by an unbalanced force, and an object in motion will continue in motion, constant speed and direction, unless acted on by an unbalanced force. So let's go back again to our Beaker image. So there is the law, and I forgot to mention that you definitely want to get this into your packet, so pause here if you need to write this down. And then let's come back and look at what happened to our chair and to Beaker again. So an object at rest will stay at rest unless acted on by an outside force. So that doesn't seem to apply to either of these because the chair and Beaker were both in motion when we started. So let's go to the second part that says an object in motion will remain in motion unless acted on by an outside force. So we have two objects in motion, the chair and Beaker. Beaker remained in motion, so from this definition then we can assume that no outside force acted on Beaker, which makes sense, right? There was nothing, Beaker was sitting there and nothing touched him differently than, at the beginning. He was sitting on the book, he was still sitting on the book, nothing else touched Beaker. The chair, however, something else did touch the chair, right? Because the chair hit, let me see if I can use this little drawing tool here. The chair hit the other chair in the classroom, right? So we can assume then that means that stationary chair was acted as an outside force, which caused our rolly chair to stop moving. So the motion of the rolly chair stopped because it was acted on by an outside force, in this case the stationary chair. Whereas Beaker, who started in motion, remained in motion because no outside forces acted on him. So if you, let me turn, how do I remove my little face from being in the way here? There we go. Here is what we just explained, but in writing. So why don't you pause here and read through this again just to help cement the ideas, and then take a look at your packet and make sure that you have the inertia definition, the Newton's first law of motion definition, and then your packet also asks you to draw two examples. So go ahead and stop the video here and do that.